Hello everyone. Thank you so much for viewing this video. Before we get started with discussing the contents of the video, I wanted to introduce my nonprofit, the Accelerated Training Program. Our vision is twofold. First, we want to expose all marginalized groups to cybersecurity education, as well as removing the systemic exclusion of cybersecurity education to marginalized groups. Our website is www.t-atp.org. And if you would like to partner or want to learn more, please visit our contact page where you can fill out your name, your email, and a message, and we will get back to you. And again, thank you so much for viewing the contents of this video. Please check out the nonprofit when you have a moment, and let's get to the video. Okay. Hello, everyone. Welcome to day 17. We're still in secure coding, filtering for order amidst chaos. Okay, so this is our story. After handling unrestricted file uploads and SQL injection vulnerabilities, McSkitty continued to review Santa's web apps. She stumbled upon user-submitted inputs that are unrecognizable, and some are even bordering on maliciousness. She then discovers that Santa's team hadn't updated these websites in a long time, as they clearly needed more controls to filter misuse. Can we help McSkitty research and learn a useful technique to handle that in the future? Okay, so intro. At this point, we are already aware of the security concerns regarding input validation. We should never trust user input. You should always filter or sanitize user input. Okay. Analogous to being the castle wall of your application that forms the first line of defense against an array of scenarios from harmless misuse to outright malicious intents, validating input merits the same effort as its medieval counterpart in terms of its hardening. It goes without question that insufficient effort in this space may result in attack vectors being vulnerable and consequently exploited in your application. Day 15 talked about input validation in light of unrestricted file upload, while day 16 focused on SQL injection. In this task, we will be exploring input validation in a more general sense before touching upon one of its most complex use cases, free-form text fields, followed by a quick discussion on how you may move forward in your secure coding journey beyond input validation. Okay, so input validation foundations. Generally, an effective way to validate input is to first know how a specific piece of data is going to be processed by the rest of your application. Day 15 task is a beautiful example that shows more or less the mindset required to be able to effectively tackle the specific case of unrestricted file upload. Data then goes through syntax and semantic validation checks to ensure that the user-provided values are both proper in their syntax. The answer follows the proper context asked by the question and logical value. The value makes sense for the question. Going back to day 15, we cannot manually type your CV in the input field. The form asks for a file, so it's simply not what's being asked. You cannot just upload any file. It should follow a set of very specific rules, the implementation which was all discussed in the latter parts of the task. Remember, we only wanted PDF because before we were able to upload PDF, exe, doc, we could upload anything. And in the lab, oh, spoiler alert, sorry, I'm not sure if you, the watcher, have done it, but if not, spoiler alert, it can only take PDF. Okay. Then comes whitelisting, where you can be very specific with what your forms would accept and immediately strip or even drop the ones that don't fit in the predefined allowed category. Okay, so HTML5 and regex. HTML5's built-in features help a lot with the validation of user-provided input, minimizing the need to rely on JavaScript for the same objective. The input tag it specifically has an array of very helpful capabilities centered around form validation. For instance, the input type or input tag which can be set to specifically filter for an email, a URL, or even a file, among others, promptly checks whether or not the user provided input fits the type of data that the form is asking for. And so feedback on its validity is immediately returned to the user as a result. For even more granular control of the input being provided, regular expressions, or regex, can be integrated into the mix. Simply use it in the pattern attribute with the input tag element, and you're all set. So here, we probably want to need this, is a nice resource to get started with regular expressions. A couple of examples are shown below. So we have the input tag, it's a text. So what this pattern is saying is we want alphanumeric, lowercase or uppercase in numbers. So this is saying we want an alphanumeric in this field. Email shows that we could have anything before, but it needs to end in tryhackme.com. The pattern in the first line of code above is easily one of the most foundational regular expressions one can use. The instruction here is to match any string specifically composed of only letters and numbers, an alphanumeric pattern that is case insensitive. Okay, the pattern in the second line of code above is a bit more pointed in its instruction, specifically that an email can have any character at the beginning as long as it ends with tryhackme.com, which is what I said. Developing regular expressions can be very daunting as its nature is complex. However, its capability to match very specific patterns is what makes it special. Well-built regular expressions introduce a great way to immediately filter out user-provided input that doesn't fit the specific requirements that you have set. While regular expressions are very powerful, getting the right regular expression, again, is the trick. And also the problem, because if you make your regular expression too permissive or too wide, then you allow characters that you don't want. But if you make it too restricted, then you are missing characters that you want. Okay. Let me start the machine, because we probably want to need this. Okay, well, that's loading. We can be reading. Okay. Okay, so regex 101. This section will talk about some regex tips to get you started. To match any lowercase character from the English alphabet, the regex pattern is lowercase a through z. We can just deconstruct it as follows. The square bracket indicates that you're trying to match one character within the set of characters inside of them. For example, if we're trying to match any vowel of the English alphabet, we construct our regex as follows: A, E, I, O, U, sometimes Y. The order of the characters doesn't matter, and it will match the same. Square brackets can also accept a range of characters by adding a hyphen, as shown in our original example. You can also mix and match sets of characters within the bracket. So we have lowercase a through z, uppercase a through z, means you want to match any character from the English alphabet regardless of case. While a through z, 0 through 9, means you want to match any lowercase alphanumeric character. So that's very important. This is case sensitive. So if you only have lowercase a through z or uppercase a through z, it's only going to match that case. If you want both, you have to specify both, lower and upper. Okay. We also need to talk about regex operators. The simplest one is the wildcard operator denoted by a period. This means regex will match any character and is quite powerful when used with the operators star, plus, and min-max. The asterisk or star operator is used if you don't care if the preceding token matches anything or not, while the plus operator is used if you want to make sure that it matches at least one. The curly braces operator, on the other hand, specifies the number of characters you want to match. Let's look at the following examples. To match a string that is alphanumeric and case insensitive, our pattern will be lowercase a through z, uppercase a through z, 0 through 9, plus. The plus operator means that we want to match a string, and we don't care how long it is, as long as it's composed of letters and numbers regardless of their case. If we want to ensure that the first part of the string is composed of letters, and we want it to match regardless if there are numbers thereafter, it will be caret A through Z, upper and lowercase, plus 0 through 9, star, dollar sign. The caret and dollar sign operators are called anchors and denote the start and end of the string we want to match, respectively. Since we want to ensure that the start of the string is composed of only letters, adding the caret operator is required. If we want to match just lowercase letters that are between 3 and 9 characters in length, our pattern would be, again, we're using the caret A through Z, 3 through 9, and then the dollar sign is to end it. And that is lowercase letters that are between 3 and 9 characters in length. If we want a string that starts with the 3 letters followed by any 3 characters, our pattern will be, again, remember the caret is to denote A through Z, upper and lowercase, 3, then the dot, because that's any, and then 3 characters. Okay. There's also the concept of grouping and escaping, denoted by parentheses and the slash operators, respectively. Grouping is done to manage the matching of specific parts of the regex better, while escaping is used so we can match strings that contain regex operators. Finally, there's a question mark operator, which is used to denote that the preceding token is optional. Let's look at the following example. If we want to match both www.tryhackme.com and tryhackme.com, our pattern will be, okay, starting with www, and we have the slash operator, tryhackme, and so here this is saying that this is optional. Like we don't, it can be there, but we don't need to have it. Tryhackme.com, and we're escaping, and then .com. Okay. The pattern will also avoid matching .tryhackme.com. Okay, so the www slash period, the caret operator marks the start of the string, followed by the grouping of www and the escape period. Right, because if we don't have this escape, then remember the period for regex is any character. So we don't want that, so we're escaping it. And immediately followed by the question mark operator. The grouping allowed the question mark operator to work its magic, matching both strings with or without the www period at the beginning. Tryhackme.com, the $ operator marks the end of the string, preceded by the string tryhackme, an escape period, and the string.com. If we don't escape the period operator, the regex engine would think that we want to match any character between tryhackme and .com as well, which is what I just said. Okay. It's also imperative to note that the wildcard operator can lead to laziness and consequently misuse. This is what I was describing earlier. As such, it's always better to use character sets through the brackets, especially when we're validating input as we want it to be perfect. And that's what I was talking about, if we make it too permissive or we restrict it too much. Here's a table to summarize everything above. So the square brackets, character set, matches any single character range of characters inside. The period is the wildcard, matches any character. The star or asterisk quantifier matches the preceding token 0 or more times. The plus quantifier matches the preceding token 1 or more times, min max. Curly brace quantifier specifies how many times the preceding token can be repeated. Parentheses, grouping, groups of a specific part of the regex for better management. Escape, escapes the regex operator so it can be matched. Question mark, optional, specifies that the preceding token is optional. Caret, anchor beginning, specifies that the consequent token is at the beginning of the string. $, anchor ending, specifies that the preceding token is at the end of the string. Okay. The unique case of free-form text. All of the techniques that we have covered in this task thus far are mainly concerned with structured data. Data that we already expect what it should look like. However, compared to the validation of structured data, free text is more complex and not very straightforward. Structured data have inherent characteristics that allows us to set them apart quite quickly. For example, names shouldn't consist of special characters. Some names have, but these can be whitelisted. And age should only consist of numbers with an absolute maximum of 3 characters. Syntax and semantic validation checks can be immediately done on them, and the chaos suddenly doesn't seem too bad. In contrast, free text fields are more free for all, and so validation checks are more limited, and the challenge of securing it is generally vaguer. Yet, like all great engineers before us, we power through these challenges and make the best with what we're given. Listed below are some considerations to ponder. First, we start again with the question of how this piece of data is going to be processed by the rest of the app. What will be the context for which this freeform text field will be used? Free text fields for blog posts are tackled very differently than text field used for a small comment section or a descriptive text field. Is the free text field necessary for your business purpose in the first place, or could it be implemented differently while still achieving the same goal? This is essential to know, too, as part of writing secure code is avoiding writing vulnerable ones. Then we get to the tricky part. Since syntax and semantic checks are pretty much impossible due to the nature of freeform text fields, our best bet in having a bit of control is through whitelisting. So this OWASP cheat sheet I'm going to open lists down the general techniques to perform whitelisting, which can be summarized as follows. Ensure no invalid characters are present through proper encoding, and whitelist expected characters and character sets. Okay, best remediation tactics. For the next part of the discussion, let's take a look at the simple base code below wherein a programmer attempts to retrieve the useful details from a user. Okay, so we have the name as Marky Mark, their birthday January 17th, 1967. Their email is markymark@tryhackme.com. They're 55. Their fave website is tryhackme, of course. And tell us more about yourself. So that's the free form. Okay. This example is a bit bare and would have been an immediate nightmare as it raises many alarms not only in terms of security, but also in terms of risking getting a ton of garbage responses. Since all of them are text inputs by default, the birthday and age fields may receive responses that aren't within their specific context. Further, malicious users have free reign over the fields, essentially allowing them a free playground to tinker with. This is the case if no input validation is done at all. Let's fix it up a bit and review again. Okay, so this is what we started with. The changes above are literally... Okay, so the changes are here. Because, yeah, this is the beginning. Okay, the changes below are literally just additions of the type attribute and their corresponding values within the input element. Yet, there's already a world of difference between this one and the base implementation prior. Take note that security wasn't the main focus of these changes, yet it succeeds in mainly alleviating the chaos that the prior implementation otherwise invited. Going back to the discussion above, this is an example of the syntax check being done in the HTML layer. However, the implementation below is still susceptible to misuse, especially for very naughty users. Let's fix it up further and review again. So what did they do here? It looked like they didn't do anything. Okay. So here, for the name, it's a required minimum length of 4 and a max of 70 with the size of 30. Okay. For the birthday, we want it to be between January 1st, 1900 and December 31st, 2014. For the email, we want the pattern. It can be anything before, but we want to make sure it has tryhackme.com. And we have the escape, because if we didn't have this escape character, this is regex, and it would assume we could have anything after the tryhackme. And we say for the email, the size is 30. And then for the favorite website, we're saying the required pattern is tryhackme. We're escaping the dot. So tryhackme.com, and we want the room, and the room can be alphanumeric, lowercase, uppercase, and letters, and it can be one or more. And we're saying this is a size of 50. Okay. The changes done above incorporate both semantic checking and whitelisting techniques to the existing syntax checking in the prior implementation in order to further filter out allowed values that can be provided in the input fields. The name field, for instance, has been written to allow a maximum of 70 characters. Still quite long, but somewhat reasonable. This can further be filtered granularly by blacklisting numbers and special symbols, but for our purposes, let's accept this for now. The date field is tweaked, so the earliest date it would allow is the year 1900, while the latest date is in 2014, with the working assumption that the youngest user of the website will be 8 years old. That's a use case that you need to verify. The email field has also been revamped to only accept Try Hack Me emails, while the URL field is further narrowed down to only accept Try Hack Me rooms as the answer to the Fave website field. These semantic checks should follow the proper business context to be effective. For example, the implementation above is geared towards the Try Hack Me staff, marked by the email field only accepting Try Hack Me emails. Furthermore, applying the foundation of input validation not only ensures that the data being provided is proper, but it is also drastically limits the attack surface of the input fields, especially those requiring structured data. Okay? This is the reason why we haven't touched the text area tag at the very end of the code block. As discussed earlier, freeform text is unique in such a way that applying syntax and semantic checks are pretty much impossible. In order to secure this one, we will first need to define what content, characters, character set, symbols, is acceptable and then perform the actual whitelisting. Even then, it wouldn't be enough as it's still a very open field, and so techniques such as output escaping and using parameterized queries, among others, should be implemented as well. So pretty much it's saying you're not going to have a silver bullet. You need to have other controls in place. Okay, client side versus server side. Our discussion until this point has been geared toward using input validation to ensure that the pieces of data that we're getting from the user are not garbage. Proper input validation on the client side limits misuse and minimizes the attack surface of the application. However, it doesn't actively cover malicious use cases. As opposed to the above example of validating input implemented on the client side, output escaping and using parameterized queries are implemented on the server side, adding computational load to the server, but ultimately helping in securing the application as a whole. This is done as an exercise of inherent distrust in the user-provided input despite validation. The example below uses the built-in HTML entities function to escape any character that can affect the application. So we see here, we have a parameter of name that we're getting from the application because we see here it's get, and we're using the quotes HTML5, and we're saying it's going to be UTF-8. On the other hand, the one below uses the HTML purifier library to help with some use cases, such as our text area conundrum above. Okay, both examples are done on the server side to escape characters and purify content, respectively, both effective ways to prevent user misuse and cross-site scripting attacks. Implementing both client and server-side validations ensure that no stones are left unturned. So here, we have, okay, this require once, and we're actually calling the HTML purifier. And then we say config, the HTML purifier config, and we're actually creating that config, and then we're saying pure now. So we're actually creating a new HTML purifier object, and we're passing in the configuration. And then the output is we're using the pure now, which is the new HTML purifier object, and we're purifying it with the input that we have. Okay. This exact case highlights the importance of layering defenses and shows point blank the limitation of client-side input validation. It also gives rise to the notion that input validation is not a one-stop shop for securing your app. Specific cases warrant specific security requirements. And so on this factor alone, it's already apparent that there exist multiple ways of attacking the challenge of securing user provided input, and most of the time they are implemented on top of each other. Okay. Not all solutions are equal. Input validation is an important layer of security that all production level applications should have. However, no matter how perfect your input validation is for your specific use case, there simply are limitations to all kinds of security implementations, and input validation is not exempt from that. You cannot make your application fully cross-site scripting proof through input validation alone. Controls may be put in place at the input level that may lessen the attack surface of the application, but it doesn't fully remediate it. Full remediation of a cross-site scripting vulnerability in your application requires additional layers of defense, such as mitigation on the browser level via secure cookies, content security policy headers, etc., and escaping and purifying user-provided input. In light of these remediation techniques, it makes sense to tackle each challenge on its own. SQL and LDAP-related vulnerabilities are addressed differently from cross-site scripting, so why try to fit them all in the same formula? Okay, our summary. Despite being a very important security control, due diligence in securing applications involving user-provided input should not stop invalidating the input per se. As seen in previous examples, user input may be validated, but it doesn't necessarily mean that it's harmless. There are a lot of tools and frameworks out there that, when used properly, can help secure your application. For instance, HTML5 features can help in minimizing input for misuse, while the use of regular expressions can help filter out what we need from the user more granularly. We take a closer look at regex here, especially because of its powerful capability to implement filters. And while the above examples aren't directly concerned about application security, they help minimize the attack surface of the application, which is further tackled through server-side validation techniques such as output escaping and using parameterized queries. We should be realistic and not try to solve all security problems with input validation. There is not one control that could prevent persistent malicious actors, and so layering these controls is the better way to move forward. Okay, so here's our exercise. We have prepared a regex exercise that you can access through the machine. Okay, we started that. First, let's start the virtual machine. Okay, we did that. To practice your regex, first change your working directory. Okay, so we're going to say desktop regex example. So we're here. Then you may either use egrep via the following syntax or the regex check Python script written for you via Python. Okay, we are aware that some structured data are more complex than others, so we have a specific syntax you may follow to make the exercise simpler. Okay, filtering out usernames, so we want alphanumeric. Okay. Okay, so if I say egrep, so I'm going to say A through Z, 0 through 9, and it's a minimum of 6, a maximum of 12. Okay. Okay, how many? What's that username? What is it? Oh, okay, so it's strings. How many usernames? One, 2, 3, 4, 5, 6. Okay, hold on. Filtering for usernames, alphanumeric, minimum of 6 characters, maximum of 12. Okay. Okay, so this is if we want lowercase in between 3 to 9. Okay. Oh, okay. I see what I didn't include the caret, and I didn't include the $sign. Okay. You see, because again, that's why the regex is important, because we were getting like a whole bunch of just crazy stuff. It's like, wait, hold on. Okay, so this is our beginning anchor and this is our ending anchor, and we're saying, hey, we want alphanumeric and we want the size between 6 and 12. So we have 2, 4, 6, 8. So we have 8. Okay. Let's see. User 35. Why? Hold on. This is kind of weird. Okay. So let me go here because I am entering it. So this should be 8. Okay. Ooh, okay. User 35. Okay. Filtering for email. So next we need a filter for email. So following the form local part at domain. Local part is a random string and the domain is in the form of domain.tld. All top level TLDs are .com. Okay, so this is a good one. Okay, so here okay. Okay, do I want to say star? Because local part is a random string. Is in the form of domain.tld. .com. I feel like I need to. Okay, I'm gonna try something. I don't think this is gonna work, but we'll see. Yeah, that didn't return anything. Okay. Okay. Let's see. Okay. How many emails fit? 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say 12. Was it 13? No. Okay. I kind of don't like that one. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this one didn't fit, and that one didn't fit because it didn't have a domain. Okay, how many unique domains are there? There's Gmail, there's AMG, there's Yahoo. So that's 3. There's Fedful, that's 4. That's Try Hack Me, Canary. Okay, so we have Gmail, AMG, Yahoo, Fedful, Try Hack Me, Yahoo, Canary, Hotmail, and Alpha. Alpha. So I'm gonna say 9. Oh wait, did I miss one? Okay. Wait, what is the domain of the email with the local part? Oh, am I missing one? Okay, hold on. Fedful.com. Okay. Hotmail. Hussein.vote. Okay. Oh, am I miss? Oh, AMG. Com. Okay. How many unique domains? Okay. Okay. Gmail, AMG. So that's 2. Yahoo, 3. Fedful. Try Hack Me. Canary. Hotmail. I said 9. Did I say 9? I think I did say 9. Okay, let me say 8. Okay. I must have counted 1 twice. Okay. Now, filtering on URLs. Oh, okay. So the regex. Sorry, I didn't mention because before I had the star in there and it didn't return anything. So this regex is saying we want anything, but we need to make sure it ends in .com. And so we're escaping this .com because if we didn't, that would return everything between our string and com. Okay, so we did that. Okay, filtering for URLs. Start with either HTTP or HTTPS, with some of the URLs having www and a TLD should exist. Okay, so we're going to say here, so it's either going to start with HTTP or HTTPS. What else? Some of the URLs have www. So with some, okay, this is some. Okay. Okay, I'm gonna say www. Okay. This HTTP, so it doesn't like that. Okay, let me see. Okay, hold on. Let me see. Because this. Okay, where did I enter first? Okay. Okay, it says. Okay. No. Okay, so if I say HTTP. Okay, because if I say this, it's going to return that. Okay, so let's first do HTTP. Okay, why? Okay, this should match. Okay. Okay. So we have. So I said, okay, let's just do HTTP. Okay. So it does HTTP and HTTPS. So as long as it has HTTP. Okay. How many URLs fit the syntax? Well, wait, how many have HTTPS? 1, 2, 3, 4, 5, 6, 7. 7. Okay. How many fit to 1, 2, 3, 4, 5, 6, 7. Wait, because this one doesn't fit. So 2, 4, 6, 8, 10, 12, 14, 16, 17, so 16. Okay. So, oh, okay, cool. Regex, I've worked with them before, but they are not my jam. And we didn't need to use this document, even though I will say with regular expressions, definitely look at this tutorial, which is really great. Also, check out this OWASP cheat sheet. Now, for this last one, my I kind of cheated because I just said, okay, display all the strings that have HTTP in them. You will notice here I got lazy because when it said filtering for URLs, it says start with either HTTP or HTTPS. Some of the URLs have www and a TLD should exist. So I was trying to do that here and it wasn't working. So then I became lazy and just said, hey, give me all of the strings that have HTTP. I did this to solve this challenge, but again, if this was for my job, I would have definitely had to follow this instruction. I kind of cheated in this case, but you shouldn't cheat. Okay, so if we want to learn more about this, there's a Linux Fundamentals module. And I hope that you learned something in this in this lab. I did, especially with regular expressions. I've only used it for like brackets. I've never used like the parentheses or like the caret and $ to look for a specific to confine it by a specific size. So that was very interesting. And this is day 17. I'm working on this. It is the 18th, but the lab 18 hasn't came out yet. So we have 8 more days until Christmas. So this should be very interesting on how we finish. And we haven't seen Bandit Yeti, but again, we're getting close to Christmas, so I know they're going to pop out. Okay, so I hope you have fun in this video. I did, and I'll see you in the next one. Have a good day or night. Bye.